This video is looking at the use of the binomial expansion in order to expand the bracket to the power 4 and to write it in this format here. So I'm going to use my handy AQA formula book. Thanks AQA. Turn to the first page and just use this formula here. The binomial expansion for a plus b to the n. The formula is given for me. All I need to do is figure out what a, b and n are in this particular question. Well, a, b and n in the same order are there, so it might just be worth jotting down for part A. A is 1, b, the second term is negative 2x, make sure you put in a negative if it's there, and n, the power, is 4. So using those, all I'm going to do is substitute them directly into this formula. So I'm going to get a to the n, well, that's just 1 to the power 4, plus n choose 1, so it's going to be 4 choose 1 multiplied by a to the n minus 1, so that'll be to the power 3 this time, multiplied by b, which is 2x. Continue in that vein, 4 choose 2, reduce the power, a by 1 to 1 squared, increase b by 1, so also squared, plus 4 choose 3, 1 to the power is 1, and negative 2x to the power 3, it's negative 2x to the power n, which is 4. Simplifying that down, I'm going to get 1 power 4 is just 1, 4 choose 1 is 4, multiplied by 1 cubed is 1, by negative 2x, plus 4 choose 2, if you don't know what 4 choose 2 is, you can just use your calculator, type it in, 4 choose 2, which is 6, so multiply 6 times 1 squared is just 1, multiplied by negative 2x squared, be careful with the negative, when I square it, be a negative times a negative, which is a positive, so 4x squared, plus 4 choose 3, again you can use your calculator if you want to, you get 4 multiplied by 1 multiplied by negative 2x cubed, negative times a negative times a negative, and again be negative, so it will be negative 8x cubed, plus negative 2x to the power 4, again this is an even power, that's will be positive, so it will be 16x to the power 4. Final bit of multiplying out gets me 1, 4 times negative 2x, negative 8x, 6 4s are 24, x squared, 4 times negative 8 is negative 32x plus 16x to the 4. So if I have a look at how I'm best to write the solution in this format, I can see I'm very likely to be correct because the last two is what I've got. So in this example, p is negative 8, and q is 24. For part B, I need to find the coefficient of x in the expansion of 2 plus x to the 9. Now, for any question on this where it just asks you for a single coefficient, there's no need to do the expansion that we did before. I'm still going to jot down now what a, b, and n are. So using the same setup, a is going to be 2, b is going to be x, n is going to be 9. Now, when I substitute them in to my same formula here, I don't actually need to carry on right to the end because I only want the coefficient of x. Now, you could just skip the first bit here and go straight to this because a single b in it, well, b is x, so that'll get me the coefficient of x. But I'm actually just going to do the first two. You see why later on when I get to part C, it can be useful to do that. So I've just thought ahead a little bit because I can see I'm going to do something with it later on, so it can be handy to just do the first few. So, using the same setup, I'm just going to go a to the power n, so it's 2 to the power 9, plus n choose 1, so it's going to be 9 choose 1, multiplied by a to the power n minus 1, so 2 to the power 8, multiplied by b, which is x. There'll be more in the whole series here, but I'm not going to need them, so I'm just going to stop there at plus 2 to the power 9. It's 500. N choose 1 is 9, so it's going to be 9 times 2 to the power 8. 2 to the power 8. X. So okay, 556 is 2000. So therefore, my coefficient from the first is 2000. right, as multiply. So, I'm going to write that here, minus 8x, and so on and so on. Write the late terms in. You want the coefficient of x, so any power x, when I multiply by something, I'll still get power greater than x. So I can ignore those for the purposes of this question. I'm then going to multiply that by the expansion of 2 plus x to the 9. The question which was 512 plus 2304x plus some more terms, which again will be higher powers of x. So I'm not going to need just to find the coefficient of x. Multiplying the terms I have got out, I'm going to get 1 times 512, 12, 1 times 2304x, and then I get minus 8x times 512. 512 is 4096, so negative 496x plus, and again this time, because I'll be doing power of x multiplied by another power of x, I'll get a higher power of x than just x on its own, which is what I want, so I don't need it. You could use it if you wanted to, but there's no need for this question. So I've got 512 plus 2304x minus 4096x, so minus 4096, I'm going to get negative 1792x, plus all the other terms which will be higher powers of x. So therefore my coefficient of x is negative 1792.